Exactly.
You're enjoying it.
Exactly. I'm so sorry to anybody watching this video. I forgot to record the first example. I will come back to it at the end so you can see it. I'm so sorry. Okay, so in this example, we had a trinomial, which means it didn't apply to any of our special cases. So the best way to factor this completely was to take out a common factor. We identified the largest common factor for all of these was 2p squared. So when I took it out, I was left with p to the 6th plus 5p cubed plus 6. Now I have the important task of identifying if this is factorable. And it is. I'm going to tell you right now that it is. What's the scariest part here? It's a p to the 6th and it's a p cubed. What if I temporarily replace those with something a lot more manageable? For example, p to the 6th is the same as p cubed squared, right? Just, do we acknowledge that p to the 6th is the same as p cubed squared? So I could temporarily replace that p cubed with a u so that when I write this, it actually looks like a quadratic. So if I replace p cubed with a u, then p to the 6th becomes u squared because that's p cubed squared plus 5u plus 6. I replaced p cubed with a u temporarily. Because now this is a quadratic and I can deal with quadratics. Those are easy for me. Oh, right here. I acknowledge that this is the same as this, correct? So if I temporarily replace that p cubed with a u, this is just u squared, which is a lot more reasonable to work with. Because my goal here is to factor, and we factor quadratics all the time.
Okay, I see now.
So I turned it into something more manageable. I'll replace it at the end so I'm not losing any value. I'm just making it easier to work with. So now, sorry, go ahead.
How do we know if it's like
If this is twice of what that is,
okay.
then I can do this.
Okay. Is that the only?
Pretty much, yeah.
Okay.
What two numbers multiply together to get a positive 6 and add to get a positive 5? 2 and 3. So now this becomes u plus 3 and u plus 2. I just factored it, right? 3 times 2 is 6. 3 plus 2 is 5. Would it have been easier if I made it an x squared instead of a u? Okay.
The u is weird.
I wanted to factor it. I wanted to break it down farther. So we look for two numbers that multiply to the third value and add to the middle value. Whenever we talk about quadratics, yes. And factoring them. Oh boy, I'm really getting nervous now. This is as factored as I can go. So now I'm going to replace the u's with the original p cubed that was there, which leaves me with p cubed plus 3 and p cubed plus 2, and then the original 2p squared that was outside.
Oh, wait. That's not too bad.
And then I'm done. I can't do anything else here.
That's for tomorrow.
This is hard. I know it's hard, and I know it's a lot,
Oh.
which is why you're getting the whole side of a sheet of paper.
So,
To the u squared, u times u turned into u squared. So when I broke it up, I just broke it up into what it was before. Yeah, I broke the p6 up into p cubed squared, and then I identified or replaced p cubed with a u temporarily.
remember, this is gonna be on the.
And then I put it back at the end. Right here.
So where did
I replaced it here
yeah,
to make it a quadratic.
P6 and then P3.
Yeah.
So where did P3 and P6?
I just temporarily removed them.
So
They still were here, I was just hiding them with the u. And then I pulled the u off at the end to reveal the original p cubed that was there.
yeah, but what happened to the piece?
I broke it down, p cubed times p, like p to the third times p to the third
Yeah.
becomes p to the sixth, correct? So I recognize that when I square it and I replace that p cubed with a u, then it becomes u squared.
Yeah.
So that's where the p to the sixth went. I turned it into p cubed squared, which I then replaced with u
So
squared.
there would be no P6 in your final one.
And not my final answer, because I'm breaking it down farther, that's the whole point.
Can you use different letters of U?
Well, we use u because in the future, we're gonna do a lot of u substitution. So we like to associate u with substituting something in. But you could use like x or a or b if you wanted to. U is just a really good standard.
Okay, and then if the exponents were like 8 and 4, would you still do
Okay, so I think that we can take a break from these extremely scary looking polynomials.
Yep.
And that is going to let us move into the zero product property.
Why do I like that?
This is actually something that we already practice, and it kind of is already common sense to us. But in math, we still have to write out the common sense things.
I don't have that.
So the zero product property tells me that if a polynomial is in factored form, and that factored polynomial is set equal to 0, then either factor could equal 0. So this is actually something that we already practice. So for example, if I had a polynomial that was x minus a, oh boy, times x minus b, and that was set equal to 0. In order for my entire polynomial to equal 0, either one of these could equal 0, correct? Because 0 times a number is still 0. So this is something we already practiced when we factor quadratics and solve them out, which means to find the zeros, I would take each of those factors separately and set them equal to 0 to solve. Again, this is something we already do with quadratics. We're just extending this now into polynomials.
So x equals a.
Well, yeah, but a and b, of course, would be some numbers. So now what we're doing is we are taking all of this factoring that we've been doing, and we are continuing to solve for x. So we're taking the factors, and we're eventually going to set them equal to 0 and solve for my zeros or my solutions. So this is full circle now. So we're going to start with something. Is everybody done writing? Sorry. Okay. So we're going to go ahead and start with the example. 3x to the 5th plus 15x equals 18x cubed. And I would like to solve this. Solve means I'm looking for my zeros. In order to get to those zeros, I still have to factor it like I have been doing. In order to factor this, what's the first thing I need to do? Miranda, what are you thinking? Right, I have to get everything on one side and have my polynomial set equal to 0. So when I do that, I get 3x to the 5th minus 18x cubed plus 15x equals 0. My end goal is to solve, but along the way, I have to hit all my factors. So how would I start to factor this? Because I know none of my special cases apply. What's my common factor here, Jalen? 3x, right? Because the biggest number I can take out of all three of those is 3, and the largest variable I can take out is an x. So when I do that, I'm left with x to the 4th minus 6x squared plus 5x, and that equals 0 still. It is just 5, yes. Good catch. Somebody's paying attention. Then what would I do?
You have to figure out what multiply together equals 3 and here what multiply together equals 6.
Other way. You were right originally. What multiplies to 5 but adds to 6, negative 6. Do we like it with the U4 with the x to the 4th in there, or would you rather do the U substitution? Okay, I like the U substitution because it's a really good process and it works every single time. So we recognize that x to the 4th is the same as x squared squared. If I go ahead and replace x squared with u, then I am able to rewrite this as 3x times u squared minus 6u plus 5. And that is most definitely factorable. Yeah, I'll show you after this one. That's fine.
Should this that u equals x squared be put?
Okay. So what two numbers multiply together to get a positive 5 and add to get a negative 6? Negative 5 and negative 1. Only options. So I get u minus 5 and I get u minus 1. And I still have that 3x out front. Once I have it as factored as I can go with the u, I replace the u with the original x squared that was there. I recognize that one of these fits one of my special cases for factoring, right? Do we recognize which one? What's wrong, Brandon?
Oh wait, maybe keep rid of it.
Do we see it or no? X squared minus 1 is a difference of squares because x times x makes x squared, sorry, and 1 times 1 makes 1. So I could use my special case here, or we could just do it where we set it equal to 0 and solve. Either way, you're going to come out to the same answers. So once I get this far, I'm going to take each of these individually, and I'm going to set them equal to 0, and I'm going to solve. This is going to give me all of my zeros. So when I set 3x equal to 0, I divide each side by 3, and I just get x equals 0. Then I set x squared minus 5 equal to 0. To solve for x, I have to add the 5 over. And then what? How do I get x by itself? Square root, both sides. What is the square root of 5? Can I take the square root of 5 and get a whole number? No, so we leave it as positive negative square root of 5.
Okay, I just did the square root of this calculator and it showed 5.
And it's because it's a mode that's on there.
Oh, so, okay. Oh wait, no, it showed. Okay.
We'll come back. I do the same thing with the x squared minus 1. I take that and I set it equal to 0. Add the 1 over. Square root both sides. And I get x equals plus or minus 1. Because the square root of 1 is either positive 1 or negative 1.
Why is it plus and minus?
Because negative 2 times negative 2 equals 4, but so does 2 times 2. So we have to include both the positive and the negative options that it could be, because I don't know what it originally started with. Am I finished? What do you guys think? Yes. How do I know that I'm finished? How do I know I have all the zeros?
Because you have all 3. All 3.
Oh, because it's a degree 4.
No, it's a degree 5.
Oh.
Remember? We started with degree 5.
Oh.
And how many zeros do I have right now? 5. I have 2 here, 2 here, and 1 here. I know I'm finished when I have all of my zeros accounted for. Yes. Positive and negative 1 each count as separate zeros. Positive root 5 and negative root 5, and then 0.
I thought you were pointing at x squared equals 1.
No. I have 5 zeros, so I am done. I don't leave it like this, however, we have a specific way that we write our zeros, and that is in our curly brackets. I do not care, however, if you leave them as positive, negative, or if you split them up, that is your choice. They look beautiful, I know. Yeah, kind of. More like an S and a Z, but still works.
Well, it's facing the wrong way, so we can't do it like that. So I'm like, right,
As long
Madison, I'm a little bit confused by your question. And I know it's a little bit confusing, that's okay. X squared.
Oh, they
6
marked me absent again.
and not you. I'll ask you at the end because I'm not really sure what you're asking right there. Put your phone away. I will email them and see what's going on.
2 hours ago.
Okay, next example. Yes,
There's more?
of course.
Why can't we just click through?
Why can't we just stick to the two? Yeah, numbers are fake. Like, if you had like a pie, I'm not counting how many oranges I'm giving to Bob with the quadratic formula.
Yeah, that was Monday.
That was the edict. You didn't sign on. If you go to the website,
The charts.
That's a good question.
We don't need a guess in the room right here.
Okie dokie. Do we all have this written?
Yeah.
Oh, come on.
All right, guys. So take 10 minutes to write down the problem.
That's okay. You just have to do the rest as homework.
15 minutes.
This will probably be the last one we do because I do want you guys to have time to look at the homework and ask questions, which I don't think is going to be a lot of time, but we'll try. Okay. When I want to solve this, I first have to factor it. What do I have to do before I can factor it?
Move the 36 over to the left.
Get everything on the left. Sometimes you'll have to combine like terms, but not here, thank goodness. So when I do that, I get 5b cubed plus 15b squared plus 12b plus 36 and then equals 0. Oh, I heard some people say what they think we can do.
What?
Can I take a common factor out of all 4 of these terms? No, but that doesn't mean I can't group them together and take out a common factor from 2 of them. So this is going to be a factoring by grouping problem. Clearly, I'm putting the first 2 together because they are both divisible by 5. And I'm putting the last 2 together because they're both divisible by 12. Yes.
If it were to do like the first and the last one, and
If you did that, you'd have to reorder them, but sometimes, yes, that's how that works. Yeah, not very often, especially not in this class. I will usually present them to you where they're already kind of grouped. But next year, absolutely. Okay. So as I'm looking at these first 2, Christina, what can I take out of them both? A 5 and what else? I don't have an X, right? Can I take out just 1b or can I take out 2? 2, because this lowest one is a b squared and this is a b cubed, which means I can definitely take 2 out. So I'm taking a 5b squared out of both of these terms. 5 divided by 5 is 1. b cubed divided by b squared is b. 15 divided by 5 is 3. B squared divided by b squared is 1. And then I move to my second grouping. What can I take out of 12, b, and 36? 12. What I'm left with is b plus 3. Is that a good thing?
Yes.
Yeah.
Yes, because I want these two to match. Now that they do, I can rewrite this as what they share, which is the b plus 3, times what I took out of them put together. So 5b squared plus 12. It doesn't matter. A multiplication is associative, so it doesn't matter if this one is in prime.
Oh, so that'd be how you write your answer?
Well, I'm not finished. This is factored answer, yes. But we're looking to solve it. So what do I do after I factor? What do you mean by solve it?
Oh, set it equal to 0.
Set them equal to 0 and solve for my variable. I set b plus 3 equal to 0 and I solve, and I get b equals -3. So -3 is one of my zeros. I do the same thing with the 5b squared plus 12. I set it equal to 0. What's the first thing I'm going to do to get b by itself? Subtract the 12 over. So I get 5b squared equals a -12. Then what?
You're supposed to divide it by 5 by 12.
Divide everything by 5, which gives me b squared equals -12 over 5. And then we square root both sides. I'm going to pause here and let everybody catch up before we continue.
Can you do the decimal instead of?
No. We want exact values, not rounded. So as of right now, I have b equals positive negative square root of -12 over 5. What do I not like about this? There's a negative inside my square root. How do I get rid of that? We put an I out front,
I hate it.
which means I now have b equals positive negative I times the square root of 12 over 5. Am I finished?
Yes.
Technically, no.
Yes, we are finished. We are. Manifest it. Oh, you no.
I can reduce the square root of 12 because there's a perfect square in there. So I do expect simplified radical form. So we're going to take that square root of 12 and I'm going to show you how we're doing it. What multiplies together to get 12? 4 and 3. 3 is prime, 4 is not, so I can break it down farther. What multiplies together to get 4?
2 and 2.
2 and 2. So that means 12 is equal to 2 times 2 times 3. This is called our prime factorization. So when I have my prime factorization, I look for matching pairs. Do I have any? Yes, I have a 2 and a 2 I can put together. 2 times 2 is 4. And then I drop the 3 down because it can't combine with anything. Well, not everybody recognizes that 4 is a perfect square. So we break it down all the way and then build back up. From here, I can't do anything else, so I now square root both portions that I found. What's the square root of 4? And then the square root of 3 just stays the square root of 3.
I wish you would have explained this like this.
So now I have positive negative I times 2 times the square root of 3 over the square root of 5.
I would probably ended this 12 steps ago.
Why?
That would have been so nice for everyone.
Oh, wait.
I broke this down into prime factorization.
Oh.
Then 2 times 2 becomes 4.
Yeah.
4 is a perfect square. Square root of 4 is 2. Can't take the square root of 3, so it just stays the square root of 3.
The square root of 3 equals all of that.
Technically, we could go a step farther, but I will not require that of you today. We will get there.
More?
Yes.
Farther?
We would rationalize the denominator. Again, I'm not requiring that right now, but we will get there eventually.
I don't know.
You enjoy
You better
I
not
do.
teach us this next week.
How many zeros did I expect to have? 3. How many did I find?
17.
3. I have 1 here, and I have 2 here. So then I would write all 3 of them in nice, pretty curly brackets, and then I would be finished. Since we have not practiced this portion a whole lot, I really hope you're all paying attention. If you got it down to here tomorrow, I would not count it wrong because we haven't practiced this a whole lot. Okay, so if you got it here and left it, I would be okay. This pink one right here.
Okay.
That would be an acceptable answer for tomorrow on the quiz. And today on the homework, but I would like you to practice this way too. Your homework's on Canvas. There are, of course, additional problems here. There's one that involves the quadratic formula. I highly suggest you take a look at before tomorrow's quiz, but you should already know what the quadratic formula is. If not, put it on your cheat sheet. Outside of that, homework's on Canvas. Get it done, turn it in, make your cheat sheet for tomorrow, please.
My confidence of the quiz just went down 40%.
I have